Now we're moving on to the 10 problems for the typicality. And at the end of typicality, we talked about standard deviation, that some histograms, some groups of data, have a nice average. Example C here. Most of the numbers were about what was typical for this group. There were some that were bigger and some that were smaller, but on average, they behaved like a consistent pattern. Others, like A and B, seemed kind of opposite that. There was really nothing in the middle. There wasn't a typical example. Here, there were kind of two typical examples, a smaller one and a bigger one with some variation for each. For B, what was typical was to be really extreme, to be much lower or much higher than whatever the middle would be. And then some patterns of numbers just have no pattern at all. So in D, none of these seem especially representative of the sample. Yeah, there's more at the 70% bar than anywhere else, but not by a lot. So I want to keep that in mind when looking at number 9 in the 10 exercises. Some news articles make a big deal when a country has an average temperature increase well above the global average. And there's a bunch of links back in the homework that Alaska's, at the time that article was writing, has its average temperature going above average, the rate of increase. Canada's temperature is increasing faster than average. Russia's temperature is increasing faster than average. But that's not actually newsworthy. Maybe the average temperature of the planet is, but if you have any data set at all, there's going to be some things that are on the right-hand side, right? Everything on the right-hand side of a histogram is above the average. So the fact that I could pick out something and say it's on the right-hand side, it's bigger than the average, then that's completely unsurprising. Unless everything was exactly identical in the middle, something is going to be above average. And in many kinds of data, something is a lot above average. So talking about lots of countries are having a huge amount of increase more than they used to, comparing a single thing to its own history might be significant. But just taking a bunch of things that were measured at the same time and saying some of them are above average, that's not newsworthy. That's just how it works when you measure lots of things. Some things will be bigger than others, no big deal. For number 10, there are 2 portrayals of a writer's strike from 2007. One newspaper report said that the Guild had 4,434 writers working full-time, and their average salary was very big, 204,000. These people don't need to go on strike. They're making lots of money, right? In the other report, the median income of writers in the Guild is only 5,000 a year. So those people seem really poor. Of course, they should go on strike and get paid better. So what was going on? If we make a histogram for this group, the people that are Guild writers for the Writers Guild of America. So let's put how many, all histograms have how many as their up and down measurement. And at the very bottom, people who make 0. And at the very top, people who make millions of dollars. Then these headlines leave out 2 important facts. First, almost half of the Guild writers don't write anything in a given year. So their salary is 0. So almost everyone is on this bar with 0. And second, very few will be the ones who are the writers of Game of Thrones or whatever is hot that year. So there'll be a very little bit of people that get millions. And then there's people that are in between, right? I'm just guessing where these others are. Okay, so far there's this picture of a data set. Makes sense. The biggest bar is at 0, and then there's a trickle of people that actually make some money by writing. right? There would be 4,434 little green bars if I drew this well. And there would be about 4,434 in this first tall bar here. So now let's do what we understand about mean versus median. The mean was where a balance scale balanced when you look at these histograms. They add them up and divide by how many. Remember this picture? Our brains are pretty good at this. We can look at a histogram and sort of see where it will balance. So I am just kind of guessing at my histogram, but I'm going to say that if there's a few that have the big Hollywood contracts, it's going to balance somewhere in the middle, right? There's a whole bunch of weight on this side, but there's also, we'll say, some people on the other side. Maybe that doesn't look balanced. Maybe it needs to be over here. Something like that. But anyway, wherever the balance point is, that's going to be the mean. It's going to be bigger than 0. It's going to be a lot less than several million. So it turns out that the mean, their average salary was 204,000. The median was if I list them all out. So if I did that, then I would start by listing out all of these zeros. And half of this list would be zeros, right? And then we would get more. Maybe someone was paid 20,000. And maybe someone, well, let's actually start with 10,000. And then someone was paid 20,000 for writing something. And the list would keep going. And finally, all the millionaires are at the end, right? Million. So when I find the middle of the list, take those and divide by 2, I get the 5,000. The median is the middle value of the list, or if there's not a middle value, then take the 2 middle and divide by 2. But whatever, the middle of this list is going to be a small number. And that's because half the list is zeros, roughly. We don't get to the bigger numbers really at all. So that's why the median income was so small. When I sort the list and pick the middle, then I'm barely past the zeros. Yes, this is why we're teaching you about mean, which is what you can assume people mean by average, unless they're specific. Some people will lie, and median, because they're useful for different situations and they can give very different pictures about what's happening in the world.